In the last video, we had a bunch of exponent rules, and of course the equivalent statement was up here, and we worked a couple of these, and I'm going to work a few more. And here we're taking the log of 1/16 to the base 2. And when you just have to evaluate a simple log like this, the best thing to do is give it a name, like call this y. And then you can use the equivalent statement, which is b to the y equals x. 2 to the y equals 1/16. Or 1 over 16. Now you've got it in exponential form, and then you have to know a lot about negative exponents or rational exponents. In this case, negative exponents. I know that if I take 2 to the 4th power, I'll get 16, but that won't give me 1 over 16. But if you take 2 to the negative 4 power, what you do, you bring it downstairs, it becomes positive 2 to the 4th, and you do get 1 over 16. So your answer, y, is negative 4. Okay, let me get the eraser down here. All right, let's do another one. We'll do number 8. For people who have this notebook of mine, this is number 8. Doesn't really matter what the number is, does it? But the log of 10 to the 4th power, negative 4th power, base 10. Okay, again, when we want to evaluate this, of course, you may know the inverse principle, but let's suppose you don't, and what we're going to do is we'll call it y, and we'll go 10 to the y power equals 10 to the negative 4, okay? Now, that's y, not 4 there. All right, well, 10 to the y power equals 10 to the negative 4, so in order for these to be equal, y has to equal negative 4, because if you didn't take 10 to the same power, they wouldn't be equal, so y equals negative 4. Also, 10 to the x base 10 is always going to give you the x, or whatever that exponent is, because if you put an f inside an f inverse or vice versa, you're going to just cancel each other out. Okay, let's do a couple more. We'll do number 10 out of my notebook. And number 10 is the log of 1 over 81 base 3, 1/3. Log of 1 over 81. Oh, breaking my chalk. Base 1/3. Kind of a weird base there. But this is just to get you used to the whole idea. So this set of problems has very strange bases, okay? So I just give it a name. Just for fun, I'm going to call it z, because my y's sometimes look like 4s. And 1/3 to the z power, using the equivalent statement, of course, equals 1 over 81. Now, if I square 1/3, I'll get 1/9. If I cube 1/3, I'll get 1 over 27. And if I take it to the 4th power, I'll get 1 over 81. So the answer is 4. Okay? Let's take a look at number 12. Number 12 is the log of 64 base 1/4. Another weird base. And again, you do it the same way. You give it a name. I'll call it x this time. 1/4 to the x power equals 64. Okay. Well, I know that if I square 4, I'll get 16. If I take 4 to the 3rd power, I'll get 64. Okay? But I got 1/4 here. So the trick is to take 1/4 to the negative 3rd power, and that will give me 64. The reason is you apply the negative 3 to the 1, it's just 1. 1 to any power is 1, but this is 4 to the negative 3 power, brings it up and make it 64. So my answer is x equals negative 3. Okay. And in the next video, we'll do a few more, okay?